We're live. Hey, good morning, guys. How are you? You know what's weird is you're at home and uh, not really quarantined, but you're quarantined. You're home by yourself. Um, Man, I have the distinct displeasure of seeing myself on my camera every day. I need a haircut so bad it's ridiculous. Oh well. Hey, who's here? John's here. Hey, John. Good morning. How are you? You're good. I'm glad to hear you're good. Things are going well with you. You guys staying out of trouble? Mariana's here. Hey, Mariana, I have an announcement to you from Miss Potter. Hold on, let me make sure I don't mess it up. I think what she said is that she's going to change the class time today until 11:15. Let me check. Hold on. Give me a second. I don't want to mess this up. Yeah, 11:15. So if you're a sophomore, worried about what's going on with chemistry, Miss Potter said she's going to help you guys out today at 11:15. Okay? So yeah, Atticus. Good morning. How are you doing today, Atticus? You staying out of trouble? Danitza's here. Oh yeah, little pistol. It is. That's right. Demo. What's wrong? But you're all right. You're welcome here. Yuvia's here. Hey, good morning, Yuvia, and Oreo's here. Hope you guys are all doing well. Um, I have kind of a cool lesson for you guys. Actually, we're gonna do it for ninth and 10th grade today, and it has to do with the current coronavirus COVID-19 thing about like some of the math behind it. I did a video on that a while ago, like with the doubling penny, showing you guys how exponential growth works. It was just a video, it wasn't a lesson or anything. But today, I got kind of a cool exploration we're gonna do. So, um, I don't know. It just hit me this morning. I was watching a video last night, and I realized that I could put something together to help you guys, anybody else, kind of understand some of the math behind all of this in a different way than I did earlier. So I'm kind of excited about that. Hope it goes well. We'll see. Man, it's all been kind of crazy. So let's see here. We'll give everybody about another 30 seconds or so to log on and get started. I am really curious to see how today's lesson is going to go. It is kind of fun. It's something I find really interesting myself, and it's definitely approachable for students. It's not really very difficult. The math isn't it? Isn't? Oh wow, that's just a sad story demo. Been up just for this. Well, we're gonna be on with the sophomores in here in a little bit. So, I mean, you can hang out and watch this. Watch me drink coffee. You can check out my cool shirt. Ah, this shirt demo. Got it in Tahiti last year. I love this shirt. It's like super comfortable. It feels like a nice bed sheet. Fits like one too. All right, so let's go ahead and get started. What we're going to do is we are going to be reviewing the homework assignment from yesterday. In the homework assignment from yesterday, what you had to do was determine the x and y intercept. No, just the number of x-intercepts from looking at the location of the vertex and the sign of A, right? So that's what we did. So hold on, I forgot to print a copy of it. So hold on, let me get this real quick. Yeah, I know. All right, so there we go, found it. So I hope this wasn't too difficult. The only thing that's really tricky about this is finding the vertex sometimes. So Yuvia, I'm glad that I'm worth it. I hope I don't let you down. Well, I should say I'm glad just the potential of being entertained by me and educated by me. I'm glad the potential of that was enough motivation for you to get up early. Early, it's 9 o'clock, but and I hope I don't let you down. We'll see. I've been a disappointment my whole life. You can ask my mother. That's a joke, I think. All right, so hold on. It's going to print right now, hopefully. Oh yeah. And then we'll get started. All right. So let's see here. Yuvia, you got any jokes for us? Atticus loves dad jokes. Right? Hold on, I got one. I got one. I just thought of one that I have in my possession that Atticus is gonna love. Hold on, let me find it. Man, maybe I can't find it. Hold on, because I forgot what it was. I forgot how it went. Man, I'm getting old. What are you gonna do? Hmm. Nope. Can't seem to find it. Man, Atticus, you're in luck, buddy. If I can't find it, then you're off the hook. I'll find it. Watch. Maybe not. Dang. I'll have to get it for you later. Oh, well. So, Yuvia, you got to come up with a joke. You can send us a meme of the day. We could do that. Tomorrow, my plan is to share with you guys, just for fun, pictures of all of your animals, your pets. All right. So, here we go. We're good. I apologize for that. Not even a joke. That was like the joke right there. That wasn't really the joke. Yuvia, I haven't finished Tiger King. That show's disturbing. That show's very disturbing. It's like all in one. What is wrong with freedom and what is right with freedom. That show's just like every episode I watch, I feel like I have to take a shower afterwards. It just makes me feel dirty. All right, let's get to this, shall we? JP! Hey, good morning, JP. I hope you're doing well. All right, here we go. So we have to find, we have to determine the number of x-intercepts. This one right here, do you see that the vertex, it's going to be 0, negative 9. And the reason that is, well, there's a bunch of reasons, but the clue is that when b equals 0, then the y-intercept is the same as the vertex. And the y-intercept here is 0, negative 9. Do you see? Elian's here. Hey, good morning, Elian. Davy boy's here. Dang, Davy boy. All right. So, 0, negative 9, right? That's the vertex. And A, on this one, A is 1, so it's positive. That means it's going to go up like this. So this is going to have 2 x-intercepts. That's it. Uh-oh. Little pistola there. Demo got a little trouble from Miss Bell. Shame, shame. Okay. This one right here, actually, it's only these last two that we actually have to do any kind of substantial arithmetic. The rest, we can just kind of think about logically. We can even draw pictures because, picture good, word bad. So if I draw a picture of this one and I look at the vertex, it's 3, negative 4. And you would actually get the number of x-intercepts right even if you got the sign of this wrong because it doesn't change the vertical location. It just changes the horizontal location of the vertex. So 3, negative 4 is somewhere over there, and A is positive. So it's going to go up like this. So this is going to also have 2 x-intercepts. How are we doing so far? Good, 2 for 2? All right, let's see. Next one, it's the same exact vertex, right? But now, if you look, A is negative. So it's going to start here, and now it's going to go down, so 0. No x-intercepts for this one at all. Good to go? All right, now, this one's a little different. These two are kind of weird. See, look, the vertex for this one is negative 1, 0. That's right here. And the direction, it doesn't even matter. If it's going up, it has 1 x-intercept. Even if it was going down, it would only have 1 x-intercept. So this is the case where there's 1 x-intercept. Just 1. Doing good? Number 5 is the same exact way, 7, 0. 7's over here. This A is 1, so it's going up. So 1 x-intercept. How many guys got 5 for 5 right so far? Doing good, killing it. 5 for 5. How are you guys doing with all that? Let me know in the comment over here, because I feel like you probably got all those right, no problems. I'm happy with that. And if there's a question though, I would like to know so I can go back and address it. But the gap, like between what I'm saying now when you hear it, and then when you send a message and when I have to think about what I was doing 30 or 45 seconds ago, it gets kind of awkward. So I want to give you guys some time to ask questions. I don't want to dive ahead too quickly. But all of those first 5 were pretty similar. So I don't think that was too bad. Dang, Demo, you got a compliment. Okay. JP, so number 4 and 5 were a little different, right? Number 4 and 5 were different because those were on the x-axis, and when it's on the x-axis, you only have 1 x-intercept. It's weird because it doesn't cross it; it just goes and barely just touches it. For example, Here, hold on. What I'm going to do, what I'm doing right now is I'm going to set up Desmos for us, and we're gonna take a look at Desmos. So here's Desmos right here. You see this? So check this out. If you had x squared, it has a single x-intercept. Remember, for x-intercepts, y is 0. If you ever have y is 0, it's an x-intercept. So if you had, even if you had this right here, do you see? One x-intercept. It's right here at 0, 5, at negative 5, 0, one x-intercept. And even if it was going down, oops, even if it was going down, I don't need full screen, still just one x-intercept. Do you see? Yeah, so it doesn't actually cross, it just barely touches it at one spot and then goes down. So, yeah. So does that make sense? You guys all good with that? All right. Looks like it. And if not, just leave me a message in the chat right there. We'll come back to it, okay? All right, so now let's get on to the last two right here. So on these two, we have to find the vertex, right? There's a formula. We're going to use the formula. Negative b over 2a is the x-coordinate, right? And then the y-coordinate, what we do is we take this number, whatever it turns out to be, plug it in. So let's do number 6. So for number 6, b is negative 4, and a is 1. So this is just equal to 2. So the vertex is 2 comma something. So all I got to do to figure out the something is I just got to plug in 2, f of 2, right? So 2 squared minus 4 times 2 minus 1. So that's 4 minus 8 minus 1. And this is always the case, remember? Even, like, we don't really need it for this, but if these were fractions, then this shortcut can really help you. This is half as big as that, so it always turns out to be this way. Do you see? Always. So negative 5. So 2, negative 5, that's in quadrant number 4. That's down here somewhere, right? A is 1. A is positive, so it's going to have 2 x-intercepts. Good. I'm glad that makes sense, JP. See, we learn more from mistakes than we do from getting everything right. That's just begging for, like, a joke about you and your parents right there, right? Okay, so now, this one, same thing. We have to do negative b over 2a. PFG, right? Write the formula. So, let's see, negative of negative 18 divided by 2 times 3. Yeah? So this is 6. 6 goes into 18 3 times, and it's a negative times a negative, so that makes it positive, right? Yeah. Reduce before you multiply. Always and forever, amen. Reduce before you multiply. So 3. So we got to plug 3 in. So we got to do f of 3. That's going to be 3 times 3 squared. 18 times 3 is 54. And even if I didn't know that, watch, we're going to get that right here. Watch, check this out. Every single time, when you simplify this, it's going to be half as big as this. Not worrying about the sign, just the magnitude, like how large the number is, its absolute value. 3 squared is 9, times 3 is 27. And this number is going to be twice as big, you see? 18 times 3 is 54 plus 1. So that's negative 27 plus 1, which is negative 26. So our vertex is 3, negative 26. Boom! That is, once again, in the 4th quadrant, but like way down there, right? And a is positive, so once again, this very last question has 2 x-intercepts. Dang. How many of you guys got 7 out of 7? No, how many of you guys got like 6 out of 7 or 7 out of 7? Let's see. How did you do, Elian? And how did you do, Atticus? I want to know how everybody did. So just leave me a comment real quick. Let me know how you did. And yeah. So I'm curious how you guys are doing today. It's Thursday. That's almost Friday. Man. Hold on. All right. So I forgot to post the link in one of the classrooms. All right. 7 out of 7 for Danitza. Ah, yeah. So we got a bunch of 7 out of 7s here, it looks like. That's good. Yeah, that's fantastic. That's fantastic. JP with a 5, but you know what you did wrong. You learned from it. You're good. Elian and Uvia both got 7s. That's great. That's great. Um, that's cool. Hmm. All right. So I thought that was kind of straightforward. Do you guys see why we did that though? Do you guys understand that, like, if you're going to be graphing something, right, a quadratic equation, like let's say it's one like this one right here. Let's say it's one like this right here. It's not factorable, right? So if you're going to graph it, you have to find a y-intercept. There's always one, and there's always one vertex. So if you find the vertex, you can tell if there's x-intercepts or not. And so if there's none, you don't have to do anything else. All you got to do is plot your 2 points, draw your line of symmetry, maybe plug in one extra point, and you can figure out what's next. Yeah? That makes sense? Demo, I'm going to block you if you're going to be rude. All right. So, does that make sense to you guys? So look, like for example, if we had like let's say we had something like this, like 5x minus 7 squared minus, I don't know, let's say 125. Let's say plus 125. So for your y-intercept, you plug in a 0 for x, right? And so you would have, so that's 49, right? Times 5. My, oh, I apologize. I forgot to switch over to the document camera. Forgive me. There we go. Sorry about that. All right, so let's say we had this right here, and we had to graph it, right? I want to show you why looking at the vertex can save you a lot of trouble, right? So let's say we had 5x minus 7 squared plus 125, and we needed to graph it. So we plug in a 0, gives us this, and then 49 is 7 squared times 5. I'm really tired today, so I can't do math in my head. So we have 245 plus 125, and so that's going to give us 0, 7, 3. That's a crazy y-intercept, 0, 370, right? And we can tell that our vertex right off the bat is 7 and 125, right? That's in the first quadrant. You see, this is in the first quadrant, and A is positive, so it's going up. So we know that for our x-intercepts, we're not going to have any x-intercepts. So we do not even need to do the math. Yeah. Yeah, we forgive you, Ruben. So do you guys understand why I thought this might be a good exercise? That was my hope. So that my hope is this: is as you're doing more complicated things with these quadratics like we're going to do, that you don't end up wasting a bunch of time. So like, if you had a timed test, like we do when we're in class together, if you had a timed test, you can definitely run out of time trying to find x-intercepts when there aren't any. So like in the example we just did, you'd have to use inverse operations, and that would be the smartest way. I know some of you would square and change its standard form and then try to factor or use a quadratic formula. Either way, it's all a waste of time because there aren't any, and you can tell that right away. So that was my hope. Hey, if you guys still have questions about this, comments, gripes, complaints, concerns, send me a message. Also, I know quite a few of you freshmen have been kind of going along with what the sophomores are doing with those transformations of functions and stuff. And Davy Boy asked me yesterday if he could have access to the work. So I posted that in there for you guys, I think. I did, yeah. Oh, all right. And you had posted a meme. Let's see. So anyway, I'll put the link for today's review for the sophomores in Google Classroom for you freshmen as well. Second aid? I don't really know what that is, Yuvia. All right, hold on. Here, you guys can take a look. This is the meme of the day from our wonderful Little Miss Rain on My Parade. Sometimes, I don't know. What do you guys think? Is that a good one? Is that a bad one? You guys let me know. but I appreciate you sharing one with me, Yuvia. Gotta have fun, right? Gotta have a positive attitude as much as possible. Realistically, so, right? Not like everything's puppy dogs and rainbows all the time, but yeah. So humor helps us with that. Humor helps us to have a good attitude. So anyway, later today, I'm going to. So wait, let me back up. Here in just a few minutes, I'm going to start with sophomores on what we're going to be doing. First aid. Hey, Aniela, good morning. How are you doing today? All right, so here in a few minutes, I'm going to review yesterday's work with the sophomores, and those of you who are freshmen could join in if you've been following along. It's certainly accessible to you. It's something totally new. It's kind of cool. And yeah, oh, JP, that is the best I've seen all day. Anyway, so we're going to do the review for the sophomores here in a few minutes. And then later today, I got a new lesson, and all the classes are going to do the same one. And it has to do with the thing called the R value, which is essentially this. Reason we do this social distancing and why in some places are quarantined is they're trying to lower this thing called the R value. And the R value, what it essentially is how many people one person will infect. So let's say you have a population without immunity, which is what we have with this, and one person is infected. So the R value describes how contagious that disease is or that virus is. And so we have some real life applications for this right now. So real world application to some theoretical math is kind of cool. So we're going to kind of do a lesson on that and kind of get a visual for what's really happening and what we hope happens. So all that said, I will talk to you guys a little bit later today. Yeah. All right. You guys have a good morning. If you haven't eaten breakfast, go eat breakfast. Give your mom a hug. Do the dishes. Take out the trash.